Hey everyone, welcome back to our APES flipped classroom. Today we are talking about terrestrial biomes. So you'll remember from our conversation yesterday that a biome is a broad characterization including multiple ecosystems. Today we're talking about terrestrial biomes. We have two kinds of biomes, terrestrial biomes and aquatic biomes. Terrestrial meaning land biomes, and aquatic obviously having to do with water. So today we're focused on those land biomes. So we're going to learn what a biome is, what it's characterized by, what several of the biomes are, and how we can recognize them. So first, what is a biome? It's an area that shares a characteristic climate and types of life forms. So if we were to look at some examples, we have a rainforest. That's probably a very familiar biome, although it's not one we live in. We have the taiga, which is probably less familiar to you. It's frequently known as a boreal forest. So this is a far northern coniferous forest. Temperate deciduous forest is actually the biome that we live in here in southeastern Virginia. Despite the fact that we might not actually live in a forest, still our biome is considered temperate deciduous forest because it is hospitable to trees. We have grasslands, deserts, tundra, savanna, shrublands. So we have lots of different biomes, but each biome is characterized by the organisms that live there and the climate. So when we talk about the organisms that live there, we're talking about the whole community. That's the plants and the animals in a biome, and they are uniquely adapted to live in that biome. So that means that each biome is going to have characteristic life forms. So for example, in a desert, you're going to find camels, you're going to find cacti, because they share characteristics that allow them to preserve water, whether it's the waxy leaves of or waxy structure of the cactus or the water storage hump of a camel. When we talk about the shrublands or grasslands, they have lots of shrubs and wildflowers that store lots of their energy in their roots, and that allows them to recover quickly from fires that are a predominant feature of those grassland biomes. When we talk about climate, we are talking about the average annual rainfall and its patterns, and the average annual temperature of an area and its patterns. Remember, climate and weather are not the same thing. Weather is short term. Climate is the long term, over many years average of the weather in an area. So biomes have unique characteristics. Each biome can be characterized by the amount of rainfall and temperature. And so you can see this graph characterizes the biomes from most precipitation and highest average temperature, all the way down to low temperature and low rainfall. So you'll notice that both tundra and subtropical desert and temperate grassland are all very, very low amounts of rainfall, but they're very different biomes because of their different temperatures. So we can look at these as being kind of on a continuum from a hot and wet, that is a rainforest, to hot and dry, which is a desert, to cold and dry, which is tundra, or cold and icy, which would give us taiga. So rather than asking you guys to memorize each of these biomes, I want you to think about their annual temperatures and their annual precipitation. So tropical rainforest, lots of rain, very high temperatures. Tropical seasonal forests and savannas both have high temperatures and moderate rainfall. And then a subtropical desert, or what we typically think of as a desert, has very low rainfall and very high temperatures. Moving into kind of moderate temperatures, going from most rain to least rain, we have temperate rainforest, temperate seasonal forest, or a temperate deciduous forest, meaning that it is a forest that drops its leaves in the fall and winter. With less rain, you tend to have woodlands and shrublands. Shrublands are also called chaparral or Mediterranean climates. And with very little rain, we have temperate grassland. And down here in the low temperature and moderate rain area, we have taiga. Taiga tends to be pretty low rainfall, but certainly more than tundra. Now, if we look at this biome, this can also kind of predict where on Earth those biomes are going to be found. So let's take a look at a map of our biomes. And you can see that here at the high latitude, so 60 degrees north of the equator and farther, we have boreal forests or taiga and tundra. So those are the coldest biomes, which makes sense that they're the farthest from the equator because they have the least insulation. And then between 30 degrees and 60 degrees, both north and south of the equator, we get our temperate biomes. So we have temperate grasslands, we have woodlands and shrublands. We do have a little bit of subtropical desert in this zone, although if you take a look, you'll see that the subtropical deserts tend to be focused around 30 degrees latitude, both north and south of the equator. And when we talk about global wind patterns, that will start to make a certain amount of sense. And then close to the equator, we have our tropical biomes. So this is our tropical rainforest and our tropical seasonal forest, or our savannas. So close to the equator, we're going to have high temperatures and relatively high amounts of rainfall because we have lots of evaporation from the ocean and then condensation and rain. 30 degrees north of the equator, we tend to have very dry, and from 30 to 60, it gets increasingly wet, but it's cooler. And so that gives us that characteristic climate, and more than 60 degrees north, it's cold and dry. So you don't have to memorize all of these biomes, you can understand the patterns. That latitude, that distance from the equator, is what determines those temperature and precipitation patterns. So that's why we see these predictable patterns for the biomes on Earth. Now, there is one more factor that can influence the biomes and beyond latitude, and that is elevation. And so you'll see that elevation kind of mimics the effects of distance from the equator. So if you are in a mountainous region, the higher it goes, the lower the rainfall and the colder the temperature. And so we can talk about the mimic effect of latitude and elevation. So 9 biomes that we're going to learn for APES, and we just went over them, but we have tundra, which is the coldest and the driest, boreal forest, which gets slightly more precipitation and is slightly warmer, but still very cold. And then we have, in our temperate zone, we have temperate rainforest, which is wet and tends to have lots of conifers. Temperate deciduous forest, so that's our seasonal forests. Temperate grasslands, so those are in the United States known as prairies. Then shrublands are also in our temperate region. These are the chaparral or Mediterranean biomes. And then as we move down towards the equator, we get into savannas, deserts, and tropical rainforests. And so your tropical rainforests are the closest to the equator, wettest and hottest. Deserts tend to occur 30 degrees north and 30 degrees south of the equator, and they're very hot and very dry. And the savanna tends to be the transition between deserts and forests. Another unique characteristic of each biome is its nutrient availability. Again, this shapes what sorts of organisms can live there. Plants need those soil nutrients to grow, so the availability of nutrients determines which plants can survive in a biome. So if we go back to the example of the tundra, the soil is so cold that the nutrients in any dead organic matter are really not broken down by decomposers because it's too cold for decomposers to function. This results in really low soil nutrients because the climate also has very low water availability. Very few plants are able to survive in the tundra. So we have this very shallow active layer, which has very low nutrients. Below that, you're going to have the permafrost. And so because you have this shallow nutrient poor layer, when you see an image of the tundra, you'll notice that you have only very low growing plants, very few shrubs, and no trees. And that's simply because there aren't enough nutrients in the soil, nor enough depth and water in the soil to support anything else. When we talk about the tropical rainforest, because it is so green and so lush, you might think that it has very nutrient-rich soil, but in fact, because decomposition happens so fast and there is so much plant mass, tropical rainforests actually have very nutrient-poor soil. There's high competition from lots of different plant species. Remember our competition, that's going to result in lower growth for everybody. And so rather than nutrients being in the soil in the tropical rainforest, they're actually all tied up in the living things. We also have the boreal forest, or the taiga. Remember, that's very far north, so it has very low temperatures, which is going to result in low decomposition of dead organic matter. And so the boreal forest also has quite nutrient poor soil. It also tends to have very acidic soil because the conifers tend to have very acidic needles. So what does break down tends to be on the acidic side. The most nutrient-rich soil tends to be in the temperate zones. So the temperate forest particularly has lots of dead organic material, like leaves. And so those break down. You have lots of warm temperatures and moisture for decomposition. So you have very nutrient-rich soil. Grasslands also tend to have quite nutrient-rich soil. Now, we've talked about the biomes are shaped both by elevation and by latitude. What's happening and what we're seeing happen now is that biomes are shifting. As the climate is changing, their biomes are shifting their location on Earth. So this is an image from INSTAR at University of Colorado Boulder. So this is an image in 1962 of the boreal forest. And you'll notice all of this greenery here. And as you move farther north, this image is looking north, you're seeing the trees peter out and you're seeing more low growth. So you're actually seeing the borderline between the boreal forest and the tundra, or taiga and tundra. And you can see in 2004 that much of that greenery, much of the trees have actually migrated farther north, and there's less down towards the southern edge of the photo. So as that permafrost soil is melting and allowing more decomposition and more water penetration, the taiga is moving northward, and the lower latitudes are becoming too warm for the aspen and spruce that are characteristic of the taiga, and so they're actually migrating northward. Never thought you'd think of trees as migrating, did you? If we were to talk about this in our own area, so this is an image of the eastern half of the United States, and you can see that from 1960 to 1990, here in the northern part of the United States, you have lots of maples, beeches, birch, and here in the mid-Atlantic or middle region of the United States, you have lots of oaks and pines and hickory. And you can see that in our projection that the oak, pine, and hickory forests are moving north into more hospitable, because these northern regions of the United States are becoming more hospitable to them. And you can see that the maple, beech, and birch are actually not going to be there anymore because the climate is going to be too warm for them. So biomes do shift. Okay, as always, take good notes, write down any questions you have for me, and I look forward to seeing you in class tomorrow.